Okay, see this question number 77 from chapter 18 of HC Verma. So this question is actually two parts. First part says that a block will be colliding with a spring and then oscillate on the spring. Okay, the second part is talking about a concave mirror which will create the image of the block. So let's go to the first part of the question. The block has mass 50 gram, is dropped on a vertical spring of constant 500 Newton per meter from a height 10 centimeter. So the block is falling from a height 10 centimeter and sticking to the end of the spring, and then it will perform oscillations. Okay, so let's first of all find the amplitude of oscillation. So this is my spring and this is the block released from 10 centimeter. So as the block collides with the spring and then it keeps on moving down, it will reach a maximum compression of, let's say, x. The maximum compression in the spring is x. Okay, max compression in the spring. All right, so how do I find the value of x? That is very easy. Initially velocity of block is 0, and at the point of maximum compression again velocity of block will be 0. So work done by gravity will be how much? Mg h plus x. Total height falling through is h plus x, and that will be equal to energy stored in the spring, kx square by 2. There will be no initial or final kinetic energy. So mass of the block is 50 grams, so 0.05 kilogram, g is 10, h is 10 centimeter or 0.1 meter, is equal to k is given to be 500 by 2 x square. So you will get a quadratic equation over here. Okay, I could rearrange this equation to get 500 x square minus x minus 0.1 equal to 0. So when you solve this, you will get x equal to 1 plus minus under root of b square, that is 1 minus 4ac, so 4 into 500 into 0.1, so plus 200, there's a minus sign over here, right, divided by 2a, that is 1000. This will give you the answer in meters. Okay, because everything else in this equation is given in meters, so this will give the answer in meters. So you'll get x to be equal to 1 plus minus, now 200 plus 1 is approximately 200, and root of 200 will be 10 root 2 by 1000 into 100 centimeter. I am converting meter into centimeter, so these zeros will be gone. So I get this to be equal to 10 root 2 plus 0.1 centimeter. So this will come out to be equal to root 2 is 1.4. Okay, sorry, 10 will get cancelled out. This 10 will get cancelled. Root 2 plus 0.1, so 1.5 centimeter is the maximum compression. This is your max compression. Okay, now what is the equilibrium position? Equilibrium position of the block x naught is how much? Equilibrium position means what? At equilibrium, mg downwards and spring force kx naught upwards, and they should be equal to each other. So this is your equilibrium position. So for equilibrium position, x naught will be equal to mg by k. M is 0.05 kilogram, g is 10, k is 500. We get this in meter, or this will be equal to 0.05 into 10 by 5 centimeter. So this is equal to 0.1 centimeter. So this is the position of equilibrium, which is 0.1 centimeter, and the maximum compression is 1.5 centimeter. So what is the displacement from the equilibrium? This displacement from equilibrium will be x minus x naught. Let's call it a, and this will be actually equal to amplitude of oscillation. Okay, so I can write amplitude of oscillation a will be equal to x minus x naught. So 1.5 centimeter minus 0.1 centimeter. So this is 1.4 centimeter. Okay, so I solved the first part of the problem, that is finding the amplitude of the oscillation of block. Okay, so that is 1.4 centimeter. Now we have to find the image. We have to find the length in which the image of the mass oscillates. Okay, so the mirror is at a distance of 30 centimeter from the free end of the spring. This distance is 30 centimeter. Okay, and the equilibrium position of the mirror of the block is x naught equal to 0.1 centimeter. Okay, let's draw again. So this is your mirror, this is your spring in natural length, so that is 30 centimeter, and from there we go x naught further 0.1 centimeter downwards. So for this position, let me find the position of image. So this is my position of object distance, I could say. Okay, so u equal to minus of 30 plus 0.1, so minus 30.1 centimeter. Focal length of the mirror is given to be 12 centimeter, minus 12 centimeter. So I can find position of image. So 1 by v plus 1 by u equal to 1 by f. So 1 by v minus 1 by 30.1 equal to 1 by minus 12, or 1 by v equal to 1 by 30 minus 1 by 12. So when you solve this, you will get v to be approximately equal to, first of all, this is 30.1 centimeter, but I'll take it roughly to be 30. Okay, 1 by 30 minus 1 by 12. I'll take it to be roughly 1 by 30 minus 1 by 12. And when you solve this, you will get v to be equal to 20 centimeter. Okay, now amplitude of oscillation for the block is 1.4 centimeter, and this is very small compared to u and v. Okay, amplitude is much smaller than u comma v. Okay, mod value of u and mod value of v is much smaller than them, so we could use the longitudinal magnification formula. Longitudinal magnification formula, ml is how much? Ml is equal to minus m square, lateral magnification, that is minus v square by u square. Okay, so I could simply say amplitude of image divided by amplitude of object equal to minus v square by u square. So amplitude of image divided by amplitude of object is how much? That is 1.4 centimeter, is equals to minus v is how much? 20. So 20 times 20 and u is 30, so 30 times 30. I'm ignoring 30.1, I'm making it roughly 30. So I get amplitude of image to be equal to 0.62 centimeter. And the question is asking length in which the image oscillates. So the length of oscillation of image will be 2 times amplitude. Okay, so that will be 2 times 0.62, so that is 1.24 centimeter. This is the answer.